had mentioned that you should become very familiar with the special angles. And in this picture right here, we have the special angles again, but now they have both measures for these angles. So you first have the degree measure, and on top you have the corresponding radian measure. So for example, 30 degrees is the same as pi over 6, pi over 6 radians. And actually, that was one of the examples that we have done. We converted 30 degrees following this process, and we got that 30 degrees is the same as pi over 6. For practice, you could do the same for some of the other ones, but you should know then that 30 degrees is the same as pi over 6. That's something you need to memorize. You need to memorize that 45 degrees is the same as pi over 4, and that 60 degrees is the same as pi over 3, and finally, you have to memorize, I guess there's three more. You have to memorize that 90 degrees is pi over 2, pi is 180 degrees. Well, that one you really need to know because that's the relationship that you use when doing the conversion problems, when converting from one unit to the other. And 2 pi equals 0, 360 degrees. I should say 360 degrees. So the first quadrant, as I mentioned before, is the most important ones. The other ones, you can figure them out on the spot or just figure them out using reflections, but at least these ones. So one more time, 30 degrees is pi over 6, 45 degrees is pi over 4, 60 degrees is pi over 3, pi over 2 is the same as 90 degrees. Okay, so work on memorizing that. Next, we need to talk about coterminal angles. So what are coterminal angles? Coterminal angles are just angles, two angles, that when you draw them in standard position, they have the same terminal side, which in other words, said differently, that means that when you draw the picture of these angles, they look exactly the same. Their picture is identical. You cannot distinguish if all you have is the angle in front of you, unless you have uh, an arrow or a number somewhere telling you what the angle is, the picture looks identical. The initial side is the same, the terminal side is the same. And here's an example of two angles that are coterminal. 140 degrees, okay, that's the terminal side, and negative 220 degrees, which is because it's negative is measured this way. If you draw that angle, you end up landing on the same spot. So these two angles are coterminal. Their picture, initial side and terminal side, is exactly the same. Okay, so the main idea is when dealing with coterminal angles that completing a full rotation in either direction will bring you to the exact same spot. So if you have one coterminal angle and you do a 360, you end up exactly in the same spot. Okay, so doing a 360, doing a full rotation brings you back to the exact same spot. So that means that adding 360 or subtracting 360 is going to give you another terminal angle. And in this particular example, if you take 140 and you subtract 360, subtracting means you're going in this direction, in the negative direction. So if you take 140 and you subtract 360, you can do it in a calculator, you get precisely negative 220. Or you can think of it the other way around. If you have an angle that is negative 220, if you add 360, adding positive, that means you're going in this direction, in the positive direction. So negative 220 plus 360 is 140. So adding or subtracting 360 is going to give you another angle that is coterminal. And remember, coterminal means the picture is the same. Okay, that is going to be helpful because if you have a really big angle, you can bring it back, you can bring it down and to another angle that is similar and uh, is easier to deal with because the number is smaller. So for example, suppose that I have an angle of 800 degrees. Let's bring it down to another angle that has the same picture that is coterminal, but it's much smaller. So dealing with it will be smaller. So since it is much bigger than 360, the first thing we're going to do is subtract 360. It's too big, we're going to make it smaller by subtracting, and that's going to give us a coterminal angle. So how much is that? 800 minus 360. That is 444. So that angle is coterminal. Okay. The instruction says that they want the least positive angle, the smallest one, and that is between 0 and 360. So that is not between 0 and 360. We can make that smaller still. So let's do it again. 440 minus 360. How much is that? 440 minus 360. That's 80. So 80 is also a coterminal angle. So both are coterminal angles, but this is the one that, according to the instructions, that's the one they want. So our answer is going to be 80, because 80 is between 0 and 360, and is the smallest positive one. If you were to do it again, you would become negative. Picture of what that looks like. So our original angle was 800 degrees, and that's a number that is bigger than 360, so that means you go more than one revolution. In this case, you go 2, so you start here 1, 2, and then some leftover, and the leftover is 80. So if you just only do the leftover part, which is the 80, you end up in the same spot as 800. Okay. All right, so let's do another one. This one says, find the angle between 0 and 360, so pretty much the same instructions on that as example 3. That is coterminal with the following angles: 450 and 1024. Okay, so 450 is bigger, it's too big, we're going to bring it down. We subtract 360, and that is, how much is that? So 450 minus 360, that is 90. 90 is between 0 and 360, so that means we're done. If you try to do it again, you're going to become negative. You don't want that. So that's the answer. That is an angle that is coterminal with 450. All right. Now, what is the answer for that one? You can figure that one out. So you can take a moment and try to do it. All right. Now let's do it. So this is going to be, let's see. I mean, you should have paused the video. So this is 3. Let's subtract it. Subtract 360. The number, this is 1024 is too big, so we're going to bring it down. So how much is that? 1024. I'm putting this in my calculator. So you get 664. Okay, that is definitely coterminal, but is not the one we want. We want something between 0 and 360. So we do it again. 364 minus 360. That is 3 minus 360. That is 304. Okay. That is between 0 and 360, and that's the one we want. But remember, both are coterminal with that. It's just that this is the one they were asking for. Okay. When you start out with a negative angle, in that case, you want to bring it between 0 and 360. In that case, you need to add 360. You want to bring it from the negative side to the positive side. So now in this case, instead of subtracting like in these ones, we want to bring it to the positive side. So we're going to add 360. So if I start with, for example, negative 80, I would add 360. And that's going to give me a coterminal angle that is between 0 and 360. So this is 280 degrees. And that's our answer for that one. Okay. How about that one? Figure it out. Take a moment and figure it out. Okay, now let's do it. So this is going to be negative 300, negative 730 plus 360. We want to bring it to the positive side. So instead of subtracting 360, we add it. How much was that? Negative 730 plus 360. That is negative 370. Okay, that's still negative. So we need to do it again. So negative 770 plus 360, that is negative 10 degrees. That's still negative. We need to do it one more time. Negative 10 plus 360 is 350. So 350 degrees is the angle we were looking for, an angle between 0 and 350. All of these are coterminal, but the one we really wanted is that one, as per the instructions. Now, everything that we learn how to do with degrees, we need to also know how to do it with radians. Okay, so the idea is adding or subtracting 360 degrees. So what is 360 in terms of radians? If you said 2 pi, then you got that right. All right, so now we're going to do the same thing, but with radians. So now 7 pi. I want an angle between 0 and 2 pi. 7 pi is bigger than 2 pi, so we need to bring it down. And now, instead of subtracting 360, we're going to subtract 2 pi, because we're working with that system now, the radians. Okay, so subtracting 2 pi gives me 5 pi. 5 pi is still bigger than 2 pi. So we're going to do it again. 5 pi minus 2 pi, that is 3 pi. And of course, 3 pi is still bigger than just 2 pi. So we need to do it one more time. 3 pi minus 2 pi is pi. And that gives us that this is the answer. 1 pi is between 0 and 2 pi, so the answer is this. All of these are coterminal, but that's the one we're looking for. And I'm going to say one more time, the reason we want to know how to do this is because if you had a big angle, you can bring it down and work with this instead. So if we had to find something like the sine or cosine of 7 pi, we can just bring the angle down and then work with that instead. Find the sine or angle of pi, which is easier. Okay. Now, let's do the next one. 19 pi over 4, that is bigger than 2 pi, so we're going to subtract. 19 pi over 4 minus 2 pi. Okay, I want to leave the answer in terms of pi, so I'm not going to put that in the calculator because I'm going to get a decimal unless you put only the fraction. So we're just going to do it by hand. Okay, I want the common denominator to be 4. So if I want that to be 4, imagine this as being over 1. So, and then multiply times 4 on the bottom and times 4 on the top. Times 4 on the bottom becomes 4, times 4 on the top becomes 8 pi. So 2 pi is really the same thing as 8 pi over 4. And now subtracting this, now that the denominators are the same, you just subtract across the top. So this is 11 pi over 4. Now 11 pi over 4 is still bigger than 2 pi. We need to do it again. How do I know? Well, because 11 over 4, 11 divided by 4, put it on the calculator, but the light does not, is 2.75. That's bigger than 2. So the coefficient of that pi is still bigger than 2. So that's still bigger than 2 pi. So we do it one more time. 11 pi over 4 minus 2 pi. Okay, we want to subtract this. So let's do it by hand again. Subtracting the 2 pi is the same as subtracting 8 pi over 4. Now you just subtract across. 11 minus 8 is 3. 3 pi over 4. And now 3/4 is definitely between 0 and 2. And our answer is 3 pi over 4. Okay, now you should pause the video and attempt C and D. And then when you're done, compare notes with me. Okay, we're back. So let's do it. So this is going to be 14 pi over 3. That's bigger than 2 pi. So we want to bring it down. Again, how do you know that that's bigger than 2 pi? Just look at the coefficient. 14 divided by 3. If you put in your calculator 14 divided by 3, that is 4.68. That's bigger than 2. I want the coefficient to be smaller than 2. I want it to be between 0 and 2 pi. Alright, so then that means we subtract 2 pi. And then this is 14 pi over 3. Now, subtracting 2 pi when the denominator is 3, that is 6 pi. Because you imagine that is being over 1 multiplied by 3 top and bottom. So you get 6 pi on top. Now, 14 minus 6 is 8. So this is 8 pi on top over 3. Now, we need to do it one more time because 8 over 3 is still bigger than 2. 8 divided by 3 is still bigger than 2, as you can see. Okay, so we need to do it one more time. So 8 pi minus 3 minus 2 pi, 8 pi over 3. Now, subtracting 2 pi is the same as subtracting 6 pi over 3. And then 8 minus 6 is 2. So that's 2 pi over 3. And now 2/3 is definitely between 0 and 2, which is what we want. That's smaller than 2 pi, because 2/3 is smaller than 2. Okay, and that's it. Now, if you start with a negative angle in radians, then instead of subtracting 2 pi, you want to bring it to the positive side, so you're going to add 2 pi. All right, so let's add 2 pi. Okay, now the denominator should be 2, and imagine here over 1 multiplied by top and bottom by 2, you're going to get 4 pi. And that is negative 3 pi over 2. That's still negative, okay? So we need to do it again. We need to do this again. Negative 3 pi over 2 plus 2 pi is the same as adding 4 pi over 2 and adding across the tops, that gives you 1 pi. We only write pi, we don't write 1 pi. We never write 1. When the coefficient is 1, we don't write that. And that's it, we're done. That is the answer.